Okay, the last. Hi, sweetie. Hold on. No. I don't know. I need you to go color. Mommy needs the last 10 minutes. Okay, say hello. Lily. Okay. It's all right. Should I leave that in the video? I'm going to do it. Okay, Lily, I need you to go over there. Okay, say hello. And then, no, you got to go over there. You got to go over there. Okay. The last way Isaac Newton simplified is he said, you guys, the last way Isaac Newton simplified the limit definition is he said, why do we even need h at all? Exactly. What if instead we have, remember I changed this point to x, right?
Yeah.
A while ago because now we're doing them in general, right?
Yeah.
Okay, so what if he said, well, actually, what if I just took any point on the line and I'm going to call it A. So this is the point x comma f of x, and this is the point A comma f of A.
Yes.
Right? And then he said, what if we just took the slope between those 2 points and we just slowly moved A closer and closer to x.
So is it like the limit as A approaches X?
Yep. Good job, Tate. The limit as A gets closer to x.
That's wild. But I don't hate X.
Wait. So, you said why do we even need H is what you said?
That's the last thing Isaac Newton did when he was simplifying these. He's like, well, can I do it with just another point on the line? Why even put a new variable in this situation? Right?
Because the H just gets canceled anyway.
Yeah. So in this case, we're saying A is going to move closer and closer to x. Okay, so let's do one of these real quick. And so you can see how it works. And then I'll explain the homework. This is the last one, yeah. Yeah. Okay, so let's say I had, let's do the one we just did so that you can see the same answer, but I can go slower in case you didn't get the answer on that one. So we're going to do the f of x equals the square root of 3 minus x again. Okay? So f prime of x is the limit as a approaches x. So notice that when I do my function composition, I like it better because I don't have like a binomial that I'm plugging in, right? We're just replacing f of x, f of a. So I think it makes it less likely that you're going to mess up a negative somewhere.
So it's
We're doing okay? Okay, so now when I multiply by my conjugate, so far okay? So this is still my a minus b and my a plus b, so I'm still looking for my a squared minus b squared. Keep writing that up, hoping it'll instill that pattern to you guys. So 3 minus x minus 3 minus a. Okay, let me stop here. Are we doing okay? Yeah. I don't know, do your feet stink? Okay, then yeah, take your shoes off. Oh, they're itchy.
Can I keep my socks off too?
I don't care.
Parenting.
Pick your battles.
For real. Better to let this slide and just have a conversation about underage drinking later.
You got it. Or how about that she snuck like 16 suckers already today. We doing okay so far? Everybody okay? How about back over that side? You guys doing okay? Yeah, okay. So all I've done so far is done my polynomial identity, this a squared minus b squared thing, and then distributed a negative, right?
Don't the threes cancel?
The threes are going to cancel. And then what I'm going to want to do is factor out the negative just so that I can see, right? I end up with negative x plus a, right? But if I take a negative 1 out of that, I end up with x minus a.
Which is the same thing on the bottom.
Yeah.
When that takes up the 0 error.
Yep, hold on. We're going too fast.
Would you flip the x is 0?
You don't make anything 0.
When they cancel, they become 1. The h
No, he's talking about what you plug in.
Oh, nothing's going to 0. It's just that a is becoming x.
3 minus a. Stay with me. So then here, I reduce out this. This is my divide by 0 error, right? So f prime of x is my limit as a becomes x.
So then we put x
A becomes x.
Oh my days. Oh my days.
Yeah, I'm definitely watching that.
My
Yeah,
heart
it's a
wants
lot
to skip all
easier
these steps.
to not mess up on the negatives.
It's a lot easier to not mess up on the negatives, right? Okay, before I remove this so you can put your last rule on your baby blues, I just want to explain the homework. For the homework, I gave you 6 problems to do, and I did 2 of each of the 3 rules. Now, you can do any of the rules anytime. The only reason on homework I assign a specific rule is to make it way easier for us to compare and check answers next time.
Oh, that's okay.
Does that make sense? So I don't want you to think like, oh, how do I know when to do which rule? You can do any rule at any time. Yeah, some families of functions might be easier than others, but it just makes it a lot easier when I tell you what rule to do so that it's easier to find the mistake in your work or whatever, if there is one. Does that make sense? Does anyone have any questions? Okay, and then the last tip I'll give you is if you want to check your work to see if you did it right, make a table of like 1 or 2 numbers and plug them into whatever you get for your f prime equation, and then find those numbers in the graph mode like we did all last week to check our answers. That's the easiest way to check your answers. Okay, anyone else? Okay, this is the homework, and then I'll put the last, so this is the last rule for this on your baby blues, and then this is the homework. It's the same as what I don't think I put it on Canvas yet, but I did text it out already. Okay, good job, guys. And